Hey, what's up, Ziguanas? This is day 30 of the 30 Days of Z Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new programming language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. So day 30, the last day of this series, my first 30 days of Zig ever. And it was an interesting experiment. So let's jump straight into it. Do this one more time, and then the next time I stream it will be almost certainly about Ziglings. So I will do Ziglings online, in live stream, I wanted to say. And yeah, that's like a plan. So this is what is on the menu today. Types, standard types from the standard library in Zig. So I did go through, I just read what is here yesterday, and then I paid attention to some other things like file system, part of the standard library, and also a bit of HTTP, so just like in introduction. So I didn't read from here, but I asked so I didn't read exactly the docs from here, but I asked AI just to explain how HTTP in general works in Zig so that I can have a general idea. And I also went through the here it is, the multi-array list. But I just want to go through all of these, not through the source codes because it's huge. So it would take literally like 2 hours to go through each of these if we were to see the source code. And I think this is the perfect last day thing to do, that I go not through the source code of these standard types, but just to see which functions, which methods they use and how they explain them. So these are the most common ones that are here out of the box when you install Zig. So that's why I think it's important to go through them. Okay, let's start. So the first one, ArrayHashMap, map with the allocator. And let's see, what does it say? Type function, a hash table of keys and values, each stored sequentially. Insertion order is preserved. In general, this data structure supports the same operations as standard ArrayList. Deletion operators, swap remove, big O notation 1, ordered remove, big O notation n. Okay, and yeah, by the way, so I mentioned this a few times before. This series, 30 Days of Z Coding Challenge, is not meant to teach someone anything. So this is just me documenting my learning Zig process. And why I thought this might be interesting is because I've learned dozens of other programming languages before in my life. I worked with a few of them in my career, still working with a few of them. And I thought it's going to be interesting to people to see how someone who has experience in coding as a professional developer and also as a code teacher. So I was teaching code as a tutor, as a mentor. I thought I was mentoring also some people from, for example, Google. I think I had 2 of them. No, 1 from Google, 2 from Amazon, and so on. So those were specific things. So something that some specific things that I could guide these guys through for the specific things that they needed to do. So they were already working, but they needed something specific, some specific help. So this is the idea, that I document my process of learning. And it's not completely realistical because I was trying to not do anything, and I actually succeeded in that. So I didn't do anything outside of the stream. So literally everything that is here on this channel so far, that's the only thing that, and everything that I did with Zig. So I didn't practice off camera. I didn't do anything. And this is what made it a little bit harder, because it's very hard to memorize things if you don't practice a bit more. And I tried to practice as much as possible. So I did have these maybe 6 or 7 special edition streams where I just coded things live and practice the things that I learned, but this is not enough, so I would have to practice because I basically went through the entire documentation. And of course, it's not possible to learn in programming languages like by coding 5-10 hours, and that's simply not enough to learn a programming language. But I just wanted to go this as a first, let's say, first pass, that I read the docs and that I have a general idea what is there, how Zig works in general, and then to practice things that I can manage to practice in such a short period of time and without doing anything off camera. So that's why it's a bit not a usual situation. So usually I would have gone much slower through the docs and practiced more, but this is how I decided to go this time, simply because I don't think it's interesting to anyone to see how I reread the same part of the docs over and over again and practice some simple things. So I don't think that's interesting. I was thinking maybe I will do this second pass, let's say somewhere else, not here on this channel, but maybe on YouTube. I made sorry, not YouTube, I won't say Facebook. I made a page on Facebook, so maybe there I will create some second pass through the docs where I will for the second time read things and practice things more repetitively. So I will mention, once I do this, I will mention it here so that you guys can find me if you want, and that you, for the ones who want to just like see me go through this a little bit slower for the second time. But as for this channel, I'm going to, and for YouTube, I'm going to continue what I mentioned a few minutes ago. I will do Ziglinks stream, how I go through Ziglinks, and I will do aside the Ziglinks, I will also do some occasional lead code questions in Zig just to practice. So this is the plan for documenting the experience here on YouTube, learning Zig experience. And I will also do some special streams about some, let's say, topics that are not, I mean, they are about Zig, of course, but not about directly coding or reading the docs or anything like that, but more like resources about Zig and things like that. So where someone can find anything about Zig and learn from there. And so I'm going to cover this kind of topic. So Zig related, but not strictly coding like what I do in general. Hi, Robert. Good evening. How are you? Yeah, so that's the idea. And that's why why I mentioned this now, because I was reading here O1, so big O notation, so I know what it is. But I guess some of guys here don't know what it is. So that's why I'm not trying to explain here some concepts that I already know. I'm just trying to go and learn Zig myself, but I will create a tutorial after I finish. So literally today is the last day of this. So I will create a tutorial, which I will compact a little bit, so it will be not like here I'm streaming for 1 hour and more each day for a specific topic, but this tutorial will be more condensed. So it will be, let's say, 10-15 minutes about a specific topic, and then I will explain things like this, or one notation, because this tutorial will be for the beginners. So because I'm not a Zig expert now, so I'm just learning Zig myself, so I cannot teach some advanced concepts of Zig, but I can help some people who are starting learning Zig, and especially if they're starting as their first programming language. So this is where I can help at this moment. So this is the idea. I'll create a tutorial, and there I will explain things like this, big O notation and those core concepts. So if someone is confused with these things that I just mentioned and I don't explain, this is why. So this is not a beginner's tutorial, any tutorial at all. This is just me like streaming live how I learn Zig. Okay, so let's continue. We're still in the first ArrayHashMap with allocator, and they mentioned these things so far, these operations that you can use to delete and how performant they are. And let's see what's next. Modifying the hash map while iterating is allowed. However, one must understand the well-defined behavior when mixing insertions and deletion. How do you pronounce it? Deletions with iteration. A lot of Asians here. C ArrayHashMapUnmanaged for variant. Okay, so I will not read this C wherever they say C. I will not read it. Try not to. Okay, so the parameters of this type function, it's the first one is K type, the other one is V type, so generic types, the context, which is again type, namespace that provides two functions. So public function hash self K returns U32, public function equals self K, so self and 2 times K, and then usize, and those are parameters, and returns bool. The final size in the equal function represents the index of the key. So this one, the index of the key that's already inside of the map. Okay. Store hash boolean. So this is what is this related to? So these three are parameters. Context happiness with rise. Okay, so this is the fourth one. Okay, this is just like explaining this one. Okay. I thought it's a different topic, but it's the same. Let me see what Robert writes. Robert's fine. I'm great. Nice to hear that. How about you? Yeah, I'm fine today. Yesterday I was so tired I haven't slept, but today I slept a lot, so much better. And Robert says, I bench my side project game today. Oh, cool. It's somewhat simple 2D game, but runs in 7,500 to 8,550 frames per second. So I'm happy. Nice. This is, I guess, this is an experiment. Like you don't have to have so many frames per second for any human use case, except if you have something like a slowing down aspect of it or something, so that even when you slow down, that it's still performant sometimes, or you're just doing it for fun, like. And let's see what is else here. Store hash boolean when false. This data structure is biased towards cheap equal functions, and avoid storing each key's hash in the table. Setting store hash to true incurs more memory cost, but limits equal function to being called only once per insertion deletion, provided there are no hash collisions. Okay, so this is the optimization fields. It has 3 fields. So unmanaged, allocator, and context. And this is the setting by default. I guess it's unmanaged. Allocator is of this type allocator, and then context is of this type. Types unmanaged. Values, let's see. First of all, how long is this? Yeah, this is so long. So I will then, because my idea is to go through as much as possible of these things, so maybe then it's the idea is to not go through all the functions, for example, inside, because there's so many of them, and this will take a lot of time to read. I will then just focus on these things. Values, so this is going to be the last thing I will read about anything. So I will not read functions, I will just read these first few parts of explanation of the type. So parameters, fields, and values. So this is what I'm going to focus on. Let me zoom in a little bit so that you can guys see better. So the values, data type used for the multi-array list backing this map. Okay, so makes sense, because these are all, most of these types that we are going through are data structures, and they are all about data. If not all, I didn't pay attention. Data list, the multi-array list type backing this map. So in the background. So this is going to be interesting to see what they exactly mean when they say backing this map. So the data list, they use this a side structure to optimize performance or something. Entry pointers to a key and value in the backing store of this map. Modifying the key is allowed only if it does not change the hash. That makes sense. Modifying the value is allowed. Entry pointers become invalid where whenever this ArrayHashMap is modified, unless ensure total capacity and ensure unused capacity was previously used. Okay, get or put result. Get or put variants return this structure with pointers to the backing store and a flag to indicate whether the existing entry was found. Yeah, this is necessary when hashing and making hash maps. Modifying the key is allowed only if it does not change the hash. Modifying the value is allowed. Entry pointers become invalid whenever this ArrayHashMap is modified, unless, again, the same hash, the stored hash type, either U32 or void. Yeah, so void if there is nothing there. Iterator, and iterator over entry pointers. Okay, that's cool. KV, this is key value. KV pair, which has been copied out of the backing store. Okay, nice. So let's go to the next one. Let me see what Robert wrote. Robert says he's having a lot of fun with his project, of course. The speed is not of empty screen. It is on fully functional game with non-trivial logic. Oh, nice, nice. And you're doing it in Zig, I guess. And let's see here the ArrayHashMapUnmanaged. Hash table of keys and values, each stored sequentially. Again, insertion order is preserved. In general, like the previous one, in general, this data structure supports the same operations like standard ArrayListUnmanaged. So the same complexity. So this is mostly, not mostly, but it's the same like the previous one. Modifying the hash map while iterating is allowed. However, one must understand that the well-defined behavior when mixing insertions and deletions. How you pronounce this? With iteration. This is the most hard, the hardest one. Deletions. Okay. This type does not store an allocator field. The allocator must be passed in with each function call that requires it. See ArrayHashMap. So, okay. Can be initialized directly using the default field values. This type is designed to have low overhead for small numbers of entries when store hash is false and the number of entries in the map is less than 9. The overhead cost of using this one rather than the standard list is only a single pointer sized integer. Yeah, that's cool. Default initialization of the struct is deprecated. Use empty instead. So key value, so they can be generic types, and then context again. A namespace that provides these two functions. So this is the same like previous. So the context. A namespace that provides these two functions. So hash and equals. The final use size represent the index of the key that's already inside. Yeah, this is the same. Store hash bool. So it's the same. Yeah, it's the same for like the previous one. Fields, entries, which is a data list. Then they say it is permitted to access this field directly. To access after any modification to the keys, consider calling reindex. Index header. So this is a pointer to the optional index header, or optional how you read it. So they set it to null. When entries length is less than linear scan max, this remains null. Once entries length grow big enough, this field is allocated. There is an index handler followed by an array of index I structs, where I is defined by how many total indices are there. Okay, then pointer stability. STD debug safety lock. This is for multi-threading. I used to detect memory safety violations. Sorry. types, data list, entry, gather, put result, hash, iterator, key value, and managed. Okay. Values empty and self. A map containing no keys or values. And then functions we are not going to read. Let me see what you wrote. Yeah, in Zig. So Robert says he's making this game in Zig. You also skipped one message. Aha, sorry for that. Yeah, I see now. It's hard to get this fast rendering, 0.12 milliseconds per frame. It's exploratory, but also I wanted to make my own game engine, fully targeted at performance. Also, it has auto scaling of content for Windows size. Nice. Yeah, sounds interesting. So let's see here what's next. ArrayList type function, continuous global list of. It could be also, I'm pausing like here for 20 times. So it could be also interesting. Maybe one day I can make some special stream where we will speak about these kind of things, like what you guys do with Zig, which projects you're working on, and things like that. Okay, let's see ArrayList. Contiguous growable list of items in memory. This is a wraparound an array of t values of type t, initialized within it. So this is the wrapper of an array, the regular array, the low-level array, and this is our list. So this struct internally stores a standard mem allocator for memory management to manually specify an allocate function call. Yeah, this is the same like before. Parameters t type. Okay. Fields, items, which is a slice. Contents of the list. This field is intended to be accessed directly. Pointers to elements in this slice are invalidated by various functions of this array list in accordance with the respective documentation. In all cases, invalidated means that the memory has been passed to this allocator, to this allocator's resize or free function. Okay, so that's why, because it will change, either remove or resize. Then capacity, usize, how many t values this list can hold without allocating additional memory. Then allocator, types fixed writer, sentinel slice, and writer. Okay, let's go. The next one, ArrayListAligned, a contiguous global list of arbitrarily aligned items in memory. This is a wrapper around an array of t values as aligned to alignment byte addresses. In the specific alignment, if the specific alignment is null, then a line of t built-in is used, initialized within it. Okay, this is the same, like similar like before. Parameters t and alignment. So an optional U29. It's very like Y29. 29 is very. So I guess it's not a random number that they have chosen, but it's interesting to see it's 29. It's not something like 32 or 16. Fields, item slice, contents of the list. This field is intended to be accessed directly. Pointers to elements in this slice are invalid. Yeah, this is the same like before. Yeah, size free. Capacity use size, how many TI is the same. Allocator the same. Types fixed writer, sentinel slice writer. Even this is the same. Then unmanaged. So this is the same. I will not even read it. Functions that potentially allocate memory accept allocate parameter. Initialize directly or with init capacity and initialize with the init or use to own slice. Default initialization of this struct is deprecated. Use empty instead. Okay, the same here. Now this is a bit different. So this is the array with size known and that will be assessed in, how to say, in compile time, and this is the address of it. Then contents of the list. This field is intended to be accessed directly, so this is the same. Yeah, capacity size set to 0 by default. Then here they have more or less the same. I think this writer context was not there in the previous ones. And the value and array list contain no elements. Okay, which is self. Then ArrayListUnmanaged. The allocator pass this parameter to the relevant functions rather than stored in the struct itself. Okay, the same allocator must be used throughout the entire lifetime of ArrayListUnmanaged. Initialize directly, yeah, the same. Oh no, it's a bit in capacity, and yeah, it's the same. Parameters, t-type fields, the same slice like in the previous one. This is the same. Okay, so where were I? ArrayListUnmanaged, yeah. Here. Sorry. So AutoArrayHashMap, which is an ArrayHashMap with default hash. That's why auto. And equal functions. See auto context for a description of the hash and equal implementations. So parameters k-type and v-type. And this is a source code. So I'm not going to go into source code because too many things. AutoArray HashMap, then AutoArrayHashMapUnmanaged. So we covered some ArrayList versions and ArrayHashMap versions so far, which are the most commonly used data structures. Let's see what they say for this one. AutoArrayHashMapUnmanaged. So the same, it has default hash and equal functions like the regular AutoArrayHashMap. Then parameters are again key and value, entries, data list, which is just a tuple, an empty struct. Again, they say it is permitted to access this field directly after any modification to keys. Consider calling reindex. This is the same like before. When entries length is less than linear scan max, again, this was with some other hash maps the same. The same here. So data list entry, get or put result, cache iterator, KV, and so key values and managed. And a map containing no keys or else. Okay. Then AutoHashMap. This was ArrayHashMap. This is HashMap. Let me see what you guys wrote. Robert says, I'm not sure if you have seen the empty initialization. It's cool. You can call const value ArrayList i32 equals dot empty. No, I haven't seen this one so far. It's short for ArrayList i32 dot empty. Same for methods that can't fail. Sorry. Yeah, interesting. No, I haven't seen this before. Then Fairtree Games, hi, hello, welcome. Says, for your information, all non-unmanaged types are being deprecated. Aha, thanks for the info. So this is going to change in the near future. ArrayList, AutoArrayHashMap, etc. in favor, so they are deprecated in favor of the unmanaged version. 0.15 will rename all unmanaged variants as the base versions. Thanks for explaining. Robert says, yeah, for perf and memory reasons, performance and memory reasons. Okay, thank you guys for explaining. Then let's see, this is AutoHashMap, right? So this is not unmanaged, this is managed. So non-unmanaged, how you would say. So it has K and V, key value parameters, then fields unmanaged allocator and context with their respective types unmanaged, and then values, again, entry, get or put, hash iterator, kv, key iterator. So this one I haven't seen in the previous ones, right? Or I don't remember. Size and the value iterator. So this is the same like before we read. Okay. AutoHashMapUnmanaged. This one has kv again, has metadata. So I still cannot pronounce this. So like the pointer to the multiple, however you pronounce it, of optional type, and they set it to null. Okay, pointer to the metadata, current number of elements in the hash map. Okay, makes sense. Available size, so this is the, well, the size. Number of available slots before a grow is needed to satisfy the max load percentage. The capacity, that's the word I was looking for. Pointer stability, okay, like what we've seen before. And here entry, the same ones like before. And here the managed, okay. So then AutoHashMapUnmanaged BitStack. So this is the next, the first non-array related thing on this list so far. Fields, it has our one standard array list of U8s, which they call bytes. Yeah, it makes sense because it's a bit stack. And then bit length set to 0 by default. Okay, functions I will not read like I said before, but we can expect, yeah, push to stack, pop from stack, the regular ones. So pick with without removing, just picking, right? So let's see the next one, bounded array. A structure with an array and length and a length that can be used as a slice. Yeah, so because you look like slices, the slices are the pointer and length. Useful to pass around small arrays whose exact size is only known at runtime. But whose maximum size is known at comp time. Without requiring allocator. Yeah, this is cool performance-wise. Then they have some code example, actual size 32. Then A's bounded array, they set 64 elements, right? And then U8s. Then they call init with the actual size. So this is the capacity, but they are initializing only with 32 instead of 64. Then slice of the 64-byte array, and then clone creates a copy. The structure doesn't use any internal pointers. Okay. Parameters type, T of generic type, buffer capacity, use size, fields, buffer, which is, so this is, I believe, an array of type T with buffer capacity size, and then they align it with alignment here, and they set it to undefined. Okay, let's use size 0, types writer only. Bounded array, then aligned bounded array. Let me see what you guys, oh no, you haven't wrote anything new. So bounded array aligned, structure with an array, length and alignment that can be, so yeah, the previous was only array and length. This is with alignment that can be used as a slice, useful to pass around small explicitly aligned arrays whose exact size is only known at runtime, but whose maximum size is known at comp time. So like the previous bounded arrays, which are not aligned, this is just like with alignment. So parameters t, so they have this alignment U29, buffer capacity, then fields the same like before, length types writer, BufMap, BufferMap. Let me see what you guys wrote. Jorge says, hello Jorge, welcome once again. Jorge says, question mark, square bracket star, foo is a pointer to unknown amount of foo. That can be null. If it doesn't have square brackets, it's a pointer to one element. Yeah, I know if it doesn't have square brackets, it's only one element, and I know when it has square brackets, it's multi-elements, but I still haven't memorized how they officially, you know, like a pointer to a multi, blah, 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 blah. So the official term, I have to reread from the docs how they officially call it, so that I don't say something that is not correct. So I get the idea what it is, but I don't know how to say what it is to not make a mistake. And of course, I have a general idea, so I still confuse some variations of these multi pointers that point to multiple things, multiple item pointers. So BufMap is the next one. Thanks, Jorge, for explaining. BufMap copies keys and values before they go into the map and frees them when they get removed. So it's literally a buffer, right? So BufMap is used as a buffer for the HashMap. So HashMap is the field, the only one that it's here. BufMapHashMap is the type. Then the functions. Okay, I'm not going to spend time on functions like I said. BufSet is a set of strings. The BufSet duplicates strings internally and never takes ownership of strings which are passed to it. So this is just to buffer strings. So this is something like a string pool implementation, something like that. HashMap, BufSet HashMap, okay, values iterator, yeah. Then the build. Let me see what you guys say. Robert says he has to go. Have a nice evening. You too, Robert. See you next time. Have a nice one. Bye-bye. Then let's see here for the build type. Graph, pointer to a graph. Okay, shared state among all build instances. This is interesting. So they share the state. Install TLS, top level step. Uninstall TLS, top level step. Allocator. Then user input options, which is a map. Available options map, which is again available options map. And the available option list, which is ArrayList of available option type. Okay. Then verbose. So they have a bunch of these flags. So verbose, verbose link, verbose CC, verbose air, verbose LLVM, IR, BC, verbose C import, LLVM CPU features, again verbose. So this one is invalid user input is also a flag, which is Boolean, and then we have some others which are not Boolean. So reference trace, optional U32 set to null, then default step set to the pointer of step. Then top level steps, standard string ArrayHashMapUnmanaged that takes pointer to a top level step. Okay, yeah, this one has a lot of things because it's build. It's a huge one. Install prefix. So yeah, this is the first type. So far that wasn't okay. We had also these buffers that are not the data structures, but most of them that we went through are data structures. Okay, so this one, install prefix. So they are all slices, right? So install prefix, destination directory, which is an optional, library directory, executable directory, headers directory, install path, then the sysroot, which is also optional, search prefixes, so ArrayListUnmanaged. They make an array list of some slice. Okay, slice of prefixes, I guess. libc file, build root, cache root, package config, package list. So this is an optional of, what is it here? They have, so I guess they are making this as an expression in parentheses so that this is an optional of whatever first happens here, the type that you have here, so that you don't get the type of, I forgot the precedence of operators. I haven't forgotten, but I actually never tried to memorize how this happens in which order for some of these. So I can guess, and for some of them I have a general idea, but don't know by heart. So then they have a constant slice. So it's a union of package config error and a constant slice of package config package. And they take this and make it an optional type. Okay. Then args. Again, 2 slices, one is optional. No, this, I mean, array of a slice of slices, or no, I'm lost. So this is like for the syntax, sometimes I'm lost. I'm not sure if this is a slice of slices, which I think a slice of slices of U8, something like that. I believe it is. Debug log scopes, similar situation here. Like here, I mean the type. So this is, if I'm not mistaken, slice of U8 slices, and this is the same thing, but it's an optional. And here they set it to the address of empty tuple. Okay, debug compile errors, bool. So a few more flags, debug package config. And then finally, not finally, we have more. Debug stack frames count, U8, number of stack frames, capture when stack trace is recorded for debug purpose. Okay. So that makes sense. How many things you want to see when you debug stack trace? Okay, set to 0 to disable stack collection. Okay, enable darling. Use system darling installation to run cross-compiled macOS build artifacts. Yeah, it was the first time I've seen this darling. So I know the Vine for Linux, but I didn't know about this darling. I never tried to do something with macOS in this way. So this is the second time I see it in my life. So the first time was a few days ago here in Docs. Enable QEMU, Boolean, okay. Use the QEMU installation to run cross-compiled foreign architecture build artifacts, okay. Enable Rosetta. So this kind of like now looks familiar because I went through the build through Docs. I read about the general, in general, how build works. So I've seen these things there. This is just like to see the structure itself. Enable Rosetta, enable wasn't time, enable wine, glib runtimes dir. My phone is making crazy noises here. So glib's runtimes directory. It's a slice of U8s, but as optional. After following these steps, this will be the directory glib build here install. Okay, so I will not go into details because this is requiring us to know what they're doing here. Then dependency prefix, which is a slice of U8s set to an empty string, literal. Then modules, string ArrayHashMap of pointers to modules. Then name write files, string ArrayHashMap of pointers to step write file. Name lazy pets, string ArrayHashMap lazy pets. Then package hash, a slice of U8 hash of this instance's package. Empty string means that this is the root package. Okay. Available depths. I'm mapping from dependency names to package hashes. And then they have a bunch of types: assembly options, cache, dependency, dir list, executable options, generated file graph, installed your lazy path, library options, module object options, package config, package release mode, result targets, their shared library options, standard optimize options, standard target options, args, static library options, steps, system integration option, config test options, watch, and fuzz is the namespace. Okay. Yeah, this was a big one. Build. Let's see the build. So, sorry, I want to say the build was the huge one. Now I'm in DoublyLinkedList. DoublyLinkedList has a pair of pointers to both the head and the tail of the list. List elements have pointers to both the previous and the next elements in the sequence. The list can be traversed both forward and backward. Yeah, because it's double linked. Some operations that take linear big O notation and time with a singly linked list can be done without traversal in constant O1 time with the double linked list. So some operations that take linear O1 time with single linked can be done without traversal in constant O1 time with double linked list. So these are the examples: removing an element, inserting a new element before an existing element, and pushing or popping an element from the end of the list. Yeah, because it has both before and after pointers. Parameters t-type, generic one, fields first, last, and length. So the length is just a number, use size, and first and last are set to null both, and they are of type optional pointer to node. Okay. They have types that are related, or they have node. Okay. So this is then here, I believe they have a linked list. They call it single linked list. So let's just like jump over because they are related. A single linked list is headed by a single forward pointer. The elements are singly linked for minimum space and pointer manipulation overhead at the expense of the time complexity. Removal for arbitrary elements. New elements can be added to the list after an existing element or at the end of the list. Single linked lists may only be traversed if the forwarded direction, in the forwarded direction. Single linked lists are ideal for applications with large data sets and few or no removals, or for implementing a last in first out queue. Yeah, makes sense. Yep. So they have parameters t-type, fields, optional pointer to a node, set to null, and again node like double linked lists. Okay. A dynamic library, cross-platform dynamic library loading, and symbol lookup. Platform-specific functionality is available through the inner field. So this is the field they're mentioning, inner type. Okay, this is pretty small. I mean, not going to look at the functions, but the explanation is not that big. So it's cross-platform dynamic library loading and symbol lookup. Then DynamicBitSet, a bitset with a runtime known size backed by an allocated slice of view size in wrapper around DynamicBitSetUnmanaged, which keeps track of the allocator instance. Okay, fields allocator and unmanaged, DynamicBitSetUnmanaged. Okay, this is the next one I guess we are going to see. Types iterator mask int and shift int. So this is important. It's runtime known size backed by an allocated slice of view size. It's the wrapper around this one that I guess is going to be the next one. Yes. So this is the next one, DynamicBitSetUnmanaged. Again, a bitset with runtime known size backed by an allocated slice of usize. The allocator must be tracked externally by the user. So fields bit length size is 0 by default, the number of valid items in this bit set. And then they have masks field, which is the bit mask ordered with lower indices first. Padding bits at the end must be zeroed, and they have the same types here. So this is a mask, which is again, I cannot pronounce this. So this is I will not pronounce. So it's multi-items, it's a pointer, empty mask pointer. Okay. Then EnumArray, an array keyed by an enum. So an enum becomes a key for the array, backed by a dense array. If the enum is not dense, a mapping will be constructed from enum values to dense indices. This type does no dynamic allocation and can be copied by value. Okay, E and V. So enumerator, or how will you say, and the value. Fields has only one, which is the array of values of this size, the count of indexer. Then entry indexer and iterator, or the types related, and the values could be key, value, and length. Okay. EnumArray. So then EnumMap, a map keyed by the enum, backed by a bit field and a dense array. If the enum is exhaustive but not dense, a mapping will be constructed from enum values to dense indices. This type does no dynamic allocation and can be copied by value. And then again, a denominator and the value. So this is for the key. Fields BitSet, they initialize it as empty at the beginning. Then what they say about bits determine whether items are in the map. And then the values, they set to undefined, the same like the previous one. Values of items in the map. If the associated bit is 0, the value is undefined. Okay. And the same types. Yeah, I mean, it makes sense because the key can be anything that can be hashed, and enums can EnumSet of enum elements backed by bit field if the enum is exhaustive but not also the same. This type does no dynamic allocation, can be copied by value. So it has the E type as parameter. The fields is like the previous one, the types indexer and iterator. Values, key, and len. Yeah, this one doesn't have the value because sets don't have the order, the concept of the order or something like that. Okay. HashMap, well, the pure one. General purpose hash table. No order is guaranteed, and any modification invalidates live iterators. Okay. It provides fast operations, lookup, insertion, deletion, with quite high load factors, up to 80% by default, for low memory usage. For a hash map that can be initialized directly, that does not store an allocator field. See this one, if, okay, see that one, if something else. Context must be a struct type with 2 member functions, hash, self, and k are the parameters for the, so k type for the hash and self, and u64 is the return of this hash. Okay, and the second member function is the equals, so it's always like this with hash, so hash and equals. This one takes self and kk, the same type 2 times, and bool adapted, so the bool is the return value. Adapted variants of many functions are provided. These variants take pseudo key instead of a key. Their context must have the functions. Again, these two with differences here. So the first type is now, instead of k, it's pseudo key. Parameters k and v, key value, context, and max load percentage fields. These three unmanaged allocate their context with their respective types. Types unmanaged, values. Okay, it has a bit more, but this is like with HashMap, the other HashMaps that we had before. So entry, get or put result, hash iterator, key value, key iterator size, value iterator. Okay. Then the same but unmanaged version of it, based on open addressing and linear probing. A lookup or modification typically incurs only 2 cache misses. No order is guaranteed. So this is the same like before, this part at least. And only 1 byte to overhead per element. The struct itself is only 16 bytes for a small footprint. This comes at the price of handling size with U32, which should be reasonable enough for almost all use cases. The limitations are achieved from tombstones, okay? Default initialization of these structs, the struct is deprecated. Use empty instead. So this is what Robert mentioned before. Okay. So not Robert, sorry. Yeah, Robert. Parameters. Key value, key and value and context and max load percentage fields. Optional like before. Optional set to null. Size 0, variable size 0, pointer stability. You also seen before with hash maps. Types, values, okay. Then multi-array list, I went through it yesterday, so I will not go now. Options, struct, fields has a bunch of fields. Let's see. So the first one enables segfault handler. Then it's a boolean, so flag. Then VASI CWD, so current working directory. Then function, to read the explanation, function used to implement the standard file system current working directory for the VASI, and log level, so how detailed the log will be. Then log scope levels. So this is a list of, the array of, a slice of, to be exact, log scope levels. Then they have, so I will not spend time here because there are a lot of fields. I just want to go through them quickly. Page size minimum, optional use size, overrides the heap page size minimum. Okay, page size max, so the same but for the maximum. Query page size, the function which will return a use size of, so the size of the page. What is the default implementation of determining OS page size at runtime? Okay. So, hi Dev, how are you? Then FMT max depth, use size, the default max depth, okay. Crypto random seed, so cryptographical seed for the randomness. So this is a function that doesn't return anything, but it takes a buffer, which is a array of U8s, okay. Then it's set to have from this import crypto TLC Spring Zig, this nested structure, I don't know what it is, default random seed, okay. Then crypto always get random, Also, okay, now that we have a few flags. So always get random for crypto, fork safety, and keep SigPipe. Then let's see what they say. By default, disable SigPipe by setting a no-op handler for it. Set this option to true to prevent that. Note that we use a no-op handler instead of SigIGN because it will not be sorry, inherited by any child process. SigPipe is triggered when a process attempts to write to a broken pipe. By default, SigPipe will terminate the process instead of exiting. It doesn't trigger the panic handler. Sorry, so in many cases, it's unclear why the process was terminated. By capturing SigPipe instead, functions that write to broken pipes will return the ePipe error broken pipe. The program can handle it like any other error. Okay. Then we have another flag, HTTP disable TLS. By default, standard HTTP client will support HTTPS connections. Set this option to true to disable TLS support. This will likely reduce the size of the binary, but it will also make it impossible to make HTTPS connection. Okay. So by default, it is secure. HTTP enable SSL key log file, which is also a flag, and they set it to something from built-in mode. So whatever is the debug field there, it will be set to here. This enables standard HTTP client to log SSL secrets to the file specified by the SSL key log file environment variables. Creating such a log file allows other programs with access to that file to decrypt all STD HTTP client traffic made by this program. Okay, and then side channels mitigations, crypto side channels mitigations, set to crypto default side channels mitigations. Okay. So we are into queues. Let me see what you guys wrote. Dev says, seems the day has come. No more learning stuff on stream then. No, I will keep learning. I will just focus on different. So my modulus operandi will be different. So I will stream Ziglinks, my practicing Zigling, sorry. So this is this is going to be the major streaming series, like I have now, 30 days of the coding challenge. And then on a side, I will do from time to time some lead code challenges in Zig. And I will also, I mentioned this before you came, but I will just mention it again, explain it again shortly. So the third thing is that I created a Facebook page, and I will reiterate the things that I went through, because basically I went through the entire docs that covers the entire Zig, but a shallow approach, so you don't get to know all the details. And of course, I need to practice these details. This is the point. So instead of repeating this learning process here on YouTube, which I think it's going to be boring for most of the people that watch this stream, they want to see maybe something like practicing things with Zigling, so more practical things than actually me learning and reading the docs and practicing some smaller bits of data, smaller bits of code. So I will do that rereading the docs and practicing a bit deeper these basic things. I will do on a Facebook page, so that I don't bore people here. But here I will focus on Ziglings and more coding examples. That's the idea. Dev says, can I ask you some off-topic questions? Sure. Go ahead. And while you type, I will just continue here. So PriorityDequeue is the next in line. So it's for storing generic data. Initialize it within it. Provides compare function that returns order LT lesser than when its second argument should get min popped before its third argument. Order EQ. So this is another. So they're basically explaining here which compare functions what they will return. So lesser than, when its second argument should get min popped before its third argument, order equals if the arguments are of equal priority, or order greater than if the third argument should be min popped second. So basically, who has the priority? If they have the same priority and they are in the queue, so who has the priority? Okay, popping the max elements works in reverse. For example, to make pop min return the smallest number, provide function less than, and this is the example. So context void a and b of the same generic type, then they return the order, and this is the body. So they dump the context, they return standard math order a and b. So pretty straightforward. Okay. Parameters are t type, context, and the compare function, what they just explained. Fields items, which is a slice of type t, then the length of view size, then the allocator, then the context. Okay. Yep. Then the PriorityQueue for storing training data, initialize within it, provide. So this is the same. I don't need to read, but it's just a queue. It's not the queue. And parameters are pretty much the same. Fields the same. Yeah. Okay. Progress. This API is non-allocating, non-fallable, thread safe, and lock free. It has a bunch of fields again. Let's see what they start with. Terminal is the first field, SDFS file. So they, this is the progress of the, okay, got it. So the first field is terminal. Null if the current node and its children should not print on update. Then terminal mode. So for further research, we will have to look at here, but I will not do that. Maybe that's even the next one here. Terminal node, they are not here, the standard ones from, okay. Doesn't matter. Update thread, optional standard thread, redraw event, again, standard thread reset event, which is atomically set by Sigwinch, as well as the root done function. Done boolean indicates a request to shut down and reset global state. Exit atomically. Need clear, so a flag. Refresh rate in nanoseconds, U64 is a number. Initial delay in nanoseconds, again, it's a number. Rows and columns, the number, but a bit smaller than this one. Draw buffer, so a slice of U8s, accessed only by the update thread. Node parents, a slice of node parents. This is a separate array from node storage, but with the same length so that it can be iterated over efficiently without trashing too much of CPU cache. Nice. Then node storage, which is again slice of node storage. Node free list, which is a slice of node optional index. Need node free list first, which is a node optional index, one of these. So instead of having a slice, this is just like the first one on the free list. Okay. Node end index U32. Okay. And then the types related to our options node and terminal mode. Values have IPC. Okay. Let me do the next one, which is random. The engines provided here should be initialized from external source. For a thread local cryptographically secure pseudo-random number generator, use std crypto random. This one is secure pseudo-random. Okay. I mean, cryptographically secure. This is important. So I was thinking about this a few days ago. I mentioned it. So this is cool. This can be used for generating cryptographically secure encodings, right? How to name them? Be sure to use C Spring when required. Otherwise, using a normal PRNG will be faster, and so then probably this states this stands for secure. C secure pseudo random. Okay. C secure pseudo random number generator. Okay. And this is not secure. Will be faster. Okay. So this is maybe for some games it doesn't matter, but when you need a secure one, and fields has one pointer to any opaque. Any comparison of this field may result in illegal behavior, since it may be set to undefined in cases where the random implementation does not have any associated state. And the final one, field function, which is a constant pointer to the function that returns void and receives two parameters, has two parameters. One is the pointer, the other one is the buffer. Pointer is a pointer to any opaque, and buffer is slice of U8s. Okay. Then the types as conchacha, default, this one that we went through, C secure, default the non-secure random generator, ISEC64, ECG, Romu Trio, SFC64, split mix 64, XOR Oshiro 128, XOR Shiro 256. Okay. And namespaces, okay. So let me see what you wrote. Sorry. Dev says, I am in my final year of the university. Most of my dev work is web dev. All my unique credentials are done, so I can basically start a job from tomorrow. Not IG, the market is pretty bad now. Okay. Any advice? Yes, the market is pretty bad, that's sure. So, an advice. So you have multiple factors that are related to this. Like you said, market is one thing. Then you have no experience is the second thing. And also, let's say the latest things that are happening in the, not only in our like software developing industry, but in general, where people are applying for some jobs. But in our field, it's very easy to see it because we are all coders and we can use some more advanced features to apply to jobs than some regular guys. I mean, we are also regular guys, but I want to say non-programmer regular guys. And what I want to say by this, so first of all, about the market, you cannot do anything. So you can just don't bother yourself about it. The second thing is your experience. So you can do a lot of things about this. So you can work on some projects which are going to be related closely to what you want to do. So this is the highest recommendations, that you make a project and that you actually try to do. So not something like a dummy project that anyone can watch some tutorial and they can make. But let's say that you think about it like, I'm starting a business. I want to offer this as a product to my customers. So make something like a website that will sell something. So not for really to sell something. I mean, if you're lucky, you might even hit it off and then you don't need a job. But the idea is that it works and that it's a serious platform like some regular business would have. So something like that. So try to do your best to make some project and work on it, and you will learn a lot by doing this. So this is what you can do. Yes, it will take some time, but in the meantime, you can apply. So it's not like I'm not going to apply for jobs until I finish this. You can apply every day, not a problem, but don't wait for them to call you. Because in my case, for example, when I was applying for my first job, I had statistics somewhere. I don't have them. Maybe I even have them. I can dig them out someday. But if I remember correctly, I have applied, and it was like the market was better. So it was like companies were seeking for developers much more than the developers were seeking for a job, looking for a job. So it was completely different situation. And then in that time, when I applied for my first job, I think I applied for maybe 100 of jobs, and I got maybe, let's say, 15 responses at all. Some of them were like, thanks for applying, but we think that it's not the best fit. We are not going to continue, blah, blah, like the generic response. Then of these 15, so 100 applied, 15 responded, but more than half said like this. So like, no, we're not interested. And then eventually I got to maybe 5 or 6 interviews, I don't remember. And then of these 5 or 6 interviews, I went to the second and third and final round, maybe in 2 or 3 companies. And then of these 2 and 3 companies, I finally got 2 offers for the job. And I chose one. So that was, even then, it wasn't so easy to get a job if you don't apply to much more companies than you actually may think it's necessary. But now it's even worse. Now I guess you have to apply for maybe 500, 1,000 companies to get the same results, like to get called to an interview by 15 companies, like I did with 100 applications back in days. So it's just like statistics. And now we come to the third part. So I mentioned like market, you cannot do anything about it. Project we touched upon, and I just gave you an example how the market was also in my time, so more related to the first thing. And the final thing that I said is the third part, which is maybe the most important thing now to understand, is how they are processing the applications. Because 15 years ago, they read the applications manually, because simply you had a lot of companies looking for just a few developers. And then if you have, let's say, 1 position and 5 guys apply, you can read them manually. And you can just decide, I will call this guy the best, I will call them this guy first. Maybe I will also call the second guy. These 3 I'm not going to consider. But nowadays they receive, like for the one job post, they receive 1,000 applications. So it's not humanly possible to read them all. And I also have friends, because I worked in several companies. I have friends which are HRs, and I have friends which are HRs in completely different industry without like not related to development. So I have a bunch of friends that are HRs. And they all tell me that nowadays they use software to pre-process the applications. So you send a CV, they will not even read it, like the human will not read it. So they will put it into a software that will process it and try to find the match with what you write in your CV, if it matches the job description. And then let's say 30-40% of the people who apply actually don't ever get their CV read by the human, because of one mistake that they make. They put something like a photo, or I don't know, they try to format the CV nice, and that sometimes breaks the software that reads the CV, because they're not using AI, they're using some like older software that cannot parse these things. So it finds something that it doesn't understand the structure, and then it thinks that the part of your resume that is important is actually the part of the description of the image or something like that. It gets confused. And then they skip completely your resume, and then it doesn't find a match, and then it doesn't report. So it doesn't get selected, your CV doesn't get selected. So the best advice when you apply is that you, first of all, don't include any image, don't format don't use like any tables or anything, like to say experience on the left, and then in the cell in the table, like I've done this project or whatever. So education on the left column, and then on the right you put your university. Don't do that. So just like write, literally like you can open a notepad, not a Word document, and just in a notepad, what you can write there, then you copy paste into the Word, so that you don't, in the Word document, that you cannot have tables or anything like that, so that you can have a pure text. So experience like a title, a subtitle, if you will. And then as a paragraph, you say like, I worked in this company from 2005 to 2006, whatever. So it doesn't matter. So, and then you write in this way. So the structure, if you structure it like this, these softwares that are used by companies to process the CVs, they will be able to read your data. And then the second thing is try to write your CV version for every job that you apply. Try to change it a little bit, that you match the words that they mention in the job description, because of the software. So not because any other reason, but literally because the software will try to match the job description with your CV. So this is how you have higher chances to get ahead of hundreds of other people. And then still it's going to be hard, but at least you don't have these mistakes that will make you literally invisible for, let's say you send 500 times you apply for a job, and 300 or 400 of them will not even read your CV because of this. So this is how it is now. Okay, back to, so yeah, in short, my advice, apply as much as you can. Make a very, very simplified text-based CV, your curriculum, and work as you apply. Keep working on one project that is, let's say, complex one that you can represent to someone as something that is not trivial, and you can, maybe you get lucky, you'll make money with this project. So work on it like this, that you are working at a project that can potentially be something that is really, let's say, a service or a product that people want. Not because you want to do this as a business, but just like to be serious while working on this project. No problem. Let's see what is next here. So RingBuffer, I believe. This RingBuffer stores read and write indices while being able to utilize the full backing slice by incrementing the indices modulo twice the slice length and reducing the indices modulo the slice length on slice axis. Yeah, this is so abstract when you read, but it makes sense. So stores read and write indices. It's able to utilize full backing slice, and how it's able. So it increments the indices modulo twice the size length and reducing indices modulo the size length. So 2x for increases, for increment, and decrease 1x. This means that whether the ring buffer is full or empty can be distinguished by looking at the difference between the read and write indices without adding an extra Boolean flag. Yeah, that's cool. Or having to reserve a slot in the buffer. This ring buffer has not been implemented with thread safety in mind, and therefore should not be assumed to be suitable for use cases involving separate reader and writer threads. Yields data slice of U8s, then the read and write index. Okay, type slice. Okay, then segmented list. Sorry guys, my mouth went dry. So a segmented list is a stack data structure where pointers to indices have the same lifetime as the data structure itself. Unlike ArrayList, where append invalidates all existing element pointers. The trade-off is that elements are not guaranteed to be contiguous. For that, use ArrayList. However, the most elements are contiguous, making this data structure cache-friendly. Because it never has to copy elements from an old location to a new location, it does not require its elements to be copyable, and it avoids wasting memory when backed by arena allocator. Yeah, I remember this. Note that append and pop convenience methods perform a copy, but you can instead use add one, add and set capacity, and shrink capacity to avoid copying items. This data structure, okay, the complexity, time complexity, big O notation 1 and 1 for append and pop. It supports pre-allocated elements, making it especially well suited when the expected maximum size is small. Pre-allocate and count must be 0 or a power of 2. Yeah, makes sense. Parameters t-type, pre-allocate and count. And 3 fields, pre-alloc segment, which is an array of t-type of this size, and set to undefined, and then dynamic segments. So this is a multi-dimensional array. So actually, no, it's a slice of arrays. Yeah, this is like, still struggling with this syntax in Zig to understand. And this is the same thing, but you get the address of it, and it's initialized to nothing. So this is an array with nothing inside. Length is usize, okay. Const iterator and iterator are the types. Okay. Then semantic version. Software version formatted according to semantic versioning. Aha. So the fields, major, minor, patch, use size is all. Then pre and the build. So the pre, both are optional slices of constant slices of U8s, and pre and build. Okay, types range. Okay, this is cool. So this is to specify your version, right? So then we have SinglyLinkedList. I went through that one already. Static bit set returns the optimal static bit set type for the specified number of elements, either integer bit set or array bit set, both of which fulfill the same interface. Yeah, they have to, right? The return type will perform no allocations, can be copied by value, and does not require initialization, and only one parameter, use size. Okay. Okay. Then static string map, optimized for small sets of disparate string keys, works by separating the keys by length and initialization, and only checking strings of equal length at runtime. Okay. Fields. For one type V, the value fields key value. I don't know what this string, probably key value string. So it is a constant pointer to a key value string. I just want to see what it is. If it's a string, if they say okay, not going to spend time to this. I believe it's a string. Or static, S can also stand for static. Okay, so it's address of empty key KVS, then len indices. It's a constant, again, I will not try to verbalize this, like vocalize, of U32. Address of empty length, this is okay. So then len indices length set to 0, U32, min and max len, so both U32s. Max is set to 0 by default, and the minimum length is set to max integer. Okay. Yeah, because this is going to go up and this is going to go down. That's why they're kind of switching. Okay. Types KV. Okay. So this was static string map. Then we have static string map with equals. It's the same, but accepts an equality function, EQL. That function is only called to determine the equality of equal len strings. Any strings that are not equal len are never compared using the equal. Yeah, that saves time. Makes sense. Then parameters v and equal this function, which receives two. This is a constant slice of U8s, right? Two of them, and returns bool, true or false, if they're equal or not. Then the fields are 1, 2, 3, 5 of them. So KVS again, which is a constant pointer to the KVS. Address of empty KVS is the initial value. Then blanking, this is the same like before, the same like before, the same like before. Okay, so this is static string map with equals. Now we have string ArrayHashMap. So it says it's an ArrayHashMap with strings as keys. Yeah, because ArrayHashMap can have different types which are hashable as keys. It has one parameter, v, which is the type of the value, and the source code doesn't matter for now. Then we have the same thing but unmanaged. So again, same thing here, but now in fields we have the entries, which is data list, which is set to empty tuple. Okay, it is permitted to access this field directly. After any modification, consider calling reindex. Yeah, this is like at the beginning with hash maps. The same thing here, the same like at the beginning, the safety lock. Yeah, the same like the regular hash maps. So this one was unmanaged. Yeah. Then let's see string HashMap. Built-in HashMap for strings as keys. Key memory is managed by the caller. Keys and values will not automatically be freed. Then the type of the value, that's generic type, determined during the compilation time. Then fields, the three regular ones like before for similar type. So unmanaged, allocator, and context. And the values are pretty much the same like before. Okay. And then we have the same but unmanaged. So size, available size, pointer stability, yeah, the same thing like before. Then we have 5 more only. We have targets. So all the details about the machine that will be executing code, I remember this as well. So this is the compilation target. Unlike query, which might leave some things as default or host, this data is fully resolved into a concrete set of OS versions, CPU features, etc. So CPU, exactly which one, exactly which operating system, the ABI, object format, dynamic C linker. They set it up to none. Then the types that are related are ABI, C type, CPU, dynamic linker, object format, OS, query, subsystem, and bunch of namespaces. Then we have thread. Thread represents a kernel thread, and it's a struct. Most of them are structs, if not all. I haven't paid attention, but yeah, the first one was actually not. Give me a second. Type function. Yeah, not all of the are the structs, but most of them. It represents a kernel thread and acts as a namespace for concurrency primitives that operate on kernel threads. This is cool. For concurrency primitives that support both evented I/O and async I/O, see the respective names in the top level std namespace. Let me just take a look for a second there. So evented I/O, async I/O. Where are there? So probably here in I/O. Yeah, they don't have async I/O or evented I/O as the top level domain. So this one is, and then I don't see them. So maybe they're not in this one. Doesn't matter. So I will not waste time for this. It will make itself clear in the future. So the fields, IMPL, the implementation, the types, condition, ID, mutex pool, reset event, RW lock, semaphore, spawn config, and wait group. Yeah, this kind of sounds familiar. I learned about this, for example, with Java. And was it with Java? I think so. I forgot. But I never used it in my life, so that's why I don't remember. So then, yeah, I didn't want to do this. I wanted to go back to the standard one because we finished. No, I didn't. So, okay. So namespace is futex, and then the values handle max name length and use pthreads. Represents the kernel thread handle. Maybe an integer pointer. Pointer to threads. Okay. P stands for pointer then, depending on the platform. Okay. So then let's go here back to the standard library, and we have these 3 left. This is a type function, 1 parameter, which is a type, 2 fields, root, and pointer to a range, or what is P here? So the root is optional, pointer to a node, and this is empty struct, a tuple at this moment. Types entry, in order iterator, and node. Okay. So this is unclear. I'm not sure what p range stands for. I just want to see if this will hint me. Okay. No, doesn't matter. So then TZ has, it's a struct, it has 5 fields, allocator transitions, time types, leap seconds, and footer. And they are of these types. So stdmem allocator, constant slice of transition, constant slice of time type, constant slice of leap second, and a constant slice, optional constant slice of U8s. Okay. And then URI, sorry, uniform resource identifier, parsing roughly adhering to these docs here, does not do perfect grammar and character class checking, but should be robust against URIs in the wild. And it has a bunch of fields, right? Types are component and write to stream options, and about 10 of fields, so maybe 9. So scheme, okay, so URI scheme, constant slice of U8s, then user, which is optional component set to null, then password, optional component set to null, then host again, optional component set to null, then the port is optional U16 set to null, path, which is a component type, set to empty component, then the query, which is optional component set to null, and fragment set to optional set to null, which is also optional component. Okay, so yeah, I guess this makes sense because URI can be an URL, for example, that tries to access something that is behind the login wall, and that's why this has to be there. Okay. Yeah. So these are all the standard types in the standard library. So this is so huge if we go deeper into this. So this will take, so I was literally reading this for an hour and a half to go through this. So imagine how much time this takes to practice and play with these things. But yeah, this is something like I wanted to do for the last day of this challenge. Just to have something like a hint for what I'm going to research in the future. Of course, to learn completely one language and all the details about this will take years. But this is, let's say, a general idea of the most commonly used types. So in the future, when I want to do some real-world project, I'll, of course, then think about what is the probable data structure that I will use from these that will solve the problem and that will be most performant. And then I will dig deeper into that specific one that I will need. So these things I will do now, from now on, only per need basis. I'm not going to, and specifically on this channel, no. So what I mentioned before on the Facebook, I made the group. You have it in the link. So if you go to my channel, so I will show you, give me just a second to find it here actually. So I just need my, I will type it, actually, it doesn't matter. So I can do this. So if you go here, you will see that I have a link to Facebook page. It's nothing there. I just made it a few days ago. I didn't have time to do anything. And what I'm going to do there is go through these kind of things in more details there. And here on this channel, I will keep up what I said before. So I'm going to keep doing Ziglinks. That's the first series. And aside of that, I will do, whenever I have time, lead code questions in Zig. And I will speak about topics that are not directly related to coding, like Zig resources, books, videos, YouTube channels that I found interesting, and things like that. So I will do this all here on YouTube. But here, if you take a look at, so on GitHub, you already have the code that I published for these special editions. So the tic-tac-toe and inline, it's all there on GitHub. On X, I don't post anything for now, so I will do something there in the future, but not now. So the next thing that I will do, that I will start developing, is this Facebook page, which I'm going to use for what I said. So I'm going to go through the docs again, through the same chapter that I went here, but I'm going to go a bit deeper there. So if someone is interested, I'm not going to spam here the channel to do kind of the similar thing over and over again here. That's the reason. So here I'm going to do more concrete things. So concrete projects like before, like AnyLine, and these specific things like doing the Zig links path to solve and practice the code. So this will be, like I said, more live coding here, and more topics about the Zig itself, like the books I found, the other resources I found, and so on. And also we can speak about you guys and your project. So Robert is not here anymore, but he mentioned today that he's working on some Zig projects. So it would be interesting to maybe have even like a video call with Robert or anyone who wants to share their project and speak about what they are working on with Zig. So things like this for the channel. Facebook, just to go again for now through the docs, but a bit more thoroughly through the same things I went through, and that's the plan for now. Let me see what you guys wrote. Sorry, Jorge says, for example, you use the standard HTTP stuff, you need to make a URI. Yeah, this is for sure. It's going to be interesting. Once I start playing with HTTP. For requests, of course. Yeah. So you cannot. So if I understood correctly, you cannot just like use the HTTP from the standard library and just say like, this is the string that I want you to use as inside of this request. So go to this URI as a string. So it doesn't work that way. So it has to be specified as this struct, if I understood correctly, right? So yeah, that's interesting. If that is the case, because for example in Python you can literally like use a string. You say, okay, I request, and then you just like have a string and you write whatever you want in that header, and it will go and fetch something for you depending how you set things and what you ask, which HTTP method you use, and what you want to do. And Jorge answers, there's a function that parses the string to the struct. Cool. That's cool. Yeah, this is safer in my opinion, because you don't have to worry that once you have this struct that it's going to be like a typo or something. It's much easier to make a mistake in a string than in a struct, because this can break in so many times when you're making the struct manually. But of course, if there is a function, then in that case, I guess the same. If you try to call the function and provide something that does make sense, it will break, which is much easier than to try to request something that is with a typo, and then you get something that you didn't ask for and wonder why, and so on. Okay, I think this would be it for today. I am already streaming like close to 2 hours again. So what's the plan? Tomorrow, I believe I will do maybe the Zig links thing tomorrow. Maybe I will start immediately tomorrow. No, actually, no, not tomorrow. I have 1 day off of these kind of things, like streaming the learning process. But what I will then do tomorrow, I will do the next version of the AnyLine. So I want to try with files. So I want to have a game that I can save to a file, or load the pre-existing game from a file and then keep playing it. Maybe some other things that I will write into files. I'll think about those, but that's the idea. So for tomorrow, I will do the 3rd special edition for AnyLine. I will not do a regular Zig links day 1 or something like that. So just the coding practical thing. And that's the plan for tomorrow. So see you guys tomorrow. And thanks for today for being here. And let's start this new chapter. See how this is going to go. So I believe it's going to be interesting because it's going to be more practical. And yeah, that's about it for now. Thanks once again, and see you next time. Bye bye.